Hello, my name is Bruno Turkley. Kubernetes has emerged to be the dominant orchestration platform for containerized workloads. Today we want to talk about monitoring a Kubernetes cluster. What you're going to learn here is how to set up Prometheus and Grafana in a Kubernetes cluster. We're also going to learn how to do this properly with wildcard certificates to ensure secure access, preventing man-in-the-middle attacks. We're going to begin with a quick demo, then go right into the why, the what, and the how to set all this up. I think we all know the why here. We basically want secure cluster monitoring. The demo is going to show us connecting up to Grafana. Grafana connects up to Prometheus. All of this is done with HTTPS. So the user is going to come in here on grafana.turkley.com using HTTPS. That's going to connect up to the Kubernetes cluster. And the Kubernetes cluster is going to forward back through a browser to the user the current performance statistics. What we want to see here is how to build out that cluster you see here in the lower right corner. You see a number of components all done with Grafana and Prometheus, leveraging Kubernetes Helm and a couple of other technologies. So here we are in the demo. Basically, we're going to go to grafana.turkley.com with HTTPS. It's going to fire up the dashboard. And here you can see that we have a couple dashboards to choose from. Here's one that we selected just for this demo. Notice it shows the CPU, the memory, and so on of our cluster. So the technology stack here is pretty simple. We're going to be talking, of course, about Kubernetes, Prometheus, Grafana, but there's also the notion of wildcard certificates, ingress controllers, along with Nginx, Layer 4, and Layer 7 load balancers. Now the how here is pretty simple. We're going to basically leverage Helm along with some custom YAML files or manifest files for Nginx and the ingress controller. Now I'm assuming you saw my other video on wildcard certificates, easy to find. Let's quickly discuss Layer 4 and Layer 7 load balancers. You'll notice the OSI model here breaks down the different layers here, 7 of them. The top 3 represent Layer 7, and the lower one below Layer 7 is Layer 4. Layer 4 has limited network information, so the load balancing algorithm's usually quite simple, usually a round robin. Layer 7 has application awareness, so it can inspect HTTP headers, it can look at the payload, it can simply make better decisions based on the actual network traffic in terms of how it should be routed or load balanced. Prometheus is an open source monitoring system. It has a flexible query language, an efficient time series database, and alerting. If you want to learn more, just go to prometheus.io. Now Grafana is a general purpose leading open source software for time series analytics. So in our case, we're just going to use it for the visual display, the dashboard, grabbing the data from Prometheus. So we want to focus on secure access to this Kubernetes cluster. One of the ways we achieve that is by leveraging TLS, or Transport Layer Security. We will leverage X509 certificates. They will play a role in the communications across the server, making sure the traffic is encrypted. What we're trying to avoid here is the man-in-the-middle attack. Man-in-the-middle attacks are basically eavesdropping, whereby the attacker makes independent connections with the victims and relays messages between them to make them believe they are talking directly with each other over a private connection, when in fact the entire conversation is controlled by the attacker. If you're looking for more of a verbal description, a blog post, here Tim Park has a great post that discusses some of the things I discuss, so feel free to go there to get more information. Tim does a great job explaining what Helm is. Helm is basically a templating system that you can use to generalize the deployment of any set of Kubernetes resources. It also can be thought of as a package manager. It enables a community to share these best practices. So in our case, it's going to be about Prometheus and Grafana, and we're going to deploy that infrastructure using Helm charts. Here on the upper right, you'll see that a Helm chart is pre-configured Kubernetes resources. They are easy to use, easy to implement, and I'll show you how to download all the Helm charts and then make modifications for those needs that we have today for Prometheus and Grafana running on Kubernetes. One of the key files here is the values.yaml file. It's basically a set of those things that you wish to customize per deployment. Now when you finally use the Helm commands, it's going to do a substitution. So notice here the purple line, we're connecting up and taking the my company / my app and plugging it in over here to the templates deployment.yaml file. So it's kind of a search and replace. It's a way to generalize the deployment and then allow you also to customize your deployment given specific needs. So you can see here we're looking at the Kubernetes dashboard here. We essentially have just the default namespaces, no Prometheus, no Grafana. Let's look at the nodes here. Nothing surprising. We have 3 agents and 1 master node in our Kubernetes cluster. We can go here and sort by name here and see that in fact 3 agents and 1 master node. So let's go ahead now and do a very simple command. We're going to do a git clone of all the Kubernetes charts here. Pretty straightforward command. Let's go take a look now in the charts folder and see what kind of directories we have there. We have a stable and a test. Let's go to the stable directory and see if we can find both Grafana and Prometheus. Let's start with Prometheus. We see that's available. We'll go up a little bit and hopefully run across Grafana. And those are the 2 charts we're going to use to deploy to our Kubernetes cluster. Okay, so let's take a quick peek into the Prometheus values file. Let's go to the Prometheus folder. You can see values.yaml there. It's a big file, several hundred lines, but it's only a few lines that we wish to edit. And what we want to edit here is the things that we want to customize away from the default. So we're looking at the default settings here, and what we want to do is customize these settings for our cluster. You can see there's about 800 lines here. Let's go ahead and quit out and begin that process. One of the things you'll notice is that in the templates folder is the raw manifest files that we're all used to. So for example, let's say we want to look at a daemon set that is the node exporter. So we can go over here and do a quick search here and see where the daemon sets are. Now what we want to really determine here is how these things get customized, and a way to look at that is to really understand the underlying YAML file. So here is the node exporter daemon that runs on every node. It's the process that exports the performance data. You can see here that those values are going to get plugged in from the values file. So let's go there next and understand the value files a little bit better. So what we're about to look at here is the comparison between the raw and the updated values file. Now again, the values file is where we customize for our deployment away from the default values. So if we do a quick comparison, out of those 800 lines, there's only a few differences. I didn't include line numbers, but you can see here that in fact I'm going to go from a before scenario to an after. The after is the updated YAMLs file. Notice that I'm using my own host, my own domain, prom.turkley.com. Notice that there is also now the default certificate here for the secret. We're going to also be careful that when we create our certificate and our secret that it's using that actual file name of Prometheus-server-TLS. Notice a couple of the other modifications. For example, we've enabled now to true, and this really represents the finished values file for Prometheus. So notice in the before the lines are commented, therefore we uncommented them. We made some slight modifications only to a few lines. And this is basically the way you work with Helm. You go to the values file and make your modifications. So let's do the same thing we did before with Grafana this time. So I'm going to go to the Grafana folder and take a look at the values file. I'll turn in the line numbers, and you can see that in fact it is fairly big, but again, you only need to modify a little bit. So if we scoot down a little bit, you can see I've done a few things here in this one. I've enabled Nginx. I've changed my host to grafana.turkley.com and so on. Let's look at an abbreviated version of the differences between the raw, the one you get when you do a git clone, versus how I've customized it for our particular instance. So there's no mystery here. Again, notice that some of the things I changed are quite simple. As I described before, uncommenting out the Nginx line, adding the hosts here to my custom domain, making sure when I create my secret, it has a grafana-server-TLS. Also, notice my TLS host, grafana.turkley.com. Admin password, commented out. And also, I've added some custom plugins here so that when I bring up my Grafana dashboard, I can get a pie chart. And this was some of the guidance that Tim Park had given that I used. Okay, let's look at the final architecture that we're striving for. We've just finished a big chunk of it. Notice we got the Prometheus server with the Prometheus Kubernetes service. We also got the Grafana server with the Grafana Kubernetes service. In a moment, we'll take a close look at the deployment script that I've created. What it will do, it will go ahead and factor in the Nginx load balancer and SSL termination point. We'll also take a look at the creation of the secrets using the X509 certificate that we have. Again, the point here is that we can use https://grafana.turkey.com to access the layer 7 load balancer through the layer 4 load balancer, thus giving us secure access to the Grafana dashboard, giving us the performance characteristics of our Kubernetes cluster. So let's now look at my deployment file. So here, if we list out the files, you'll see deploy.sh. Let's go to that. There's some interesting lines here. It's going to provision at a high level a bunch of stuff. It's going to deploy Prometheus. It's going to deploy Grafana. It's going to deploy those additional Ingress controllers I talked about, which you will now notice are static declarative YAML files, not Helm charts. The reason is that these are extensions to the default Helm charts we saw before. I decided I wanted to have an Nginx controller that acted as a layer 7 load balancer, so you'll see 2 additional files for each of Prometheus and Grafana. The Nginx Ingress Grafana-rc file is a replication controller that will instantiate the Nginx controller. Line 19 here is essentially going to expose a layer 4 load balancer from Azure so that we can allow incoming traffic from the outside world to connect up to the Kubernetes cluster. The good news is this is going to be done via HTTPS, so it will minimize the ability for a man-in-the-middle of attack to our Kubernetes cluster. So once line 19 does that, we move to line 21, which provisions a Prometheus replication controller for the Nginx object. Now, we don't necessarily want to expose this to the outside world. The idea here is that we do want to say prometheus.turkey.com to address the Prometheus server, but we don't necessarily want to expose this to the outside world. We may want to, and so the door is left open with lines 21, 22. So in summary, lines 18, 19, 21, and 22 are provisioning Nginx replication controllers with the service. And in the case of Grafana, we've externalized to a layer 4 load balancer so that the outside world can connect up to Grafana directly. So let's do a quick review. We used Helm to install Prometheus. Next, we used Helm to install Grafana. We then took a little bit of a manual process to begin to use manifest files to add in to layer on top Nginx and some related services. And at the end of the day, we got Grafana to include a layer 4 and layer 7 load balancer with Ingress. And for Prometheus, we just set up an internal layer 7 load balancer. So that's what we did. And let's move forward a little bit more here. Okay, so let's dive into some details about some of these files. Let's take a look at all these Nginx Ingress files. There's 3 files we want to look at, 2 of them for the Ingress controller and 1 of them for the service. Notice we have 1 each for the Prometheus side and then the Grafana side. So fairly standard. The first 2 will be these replication controllers, 1 for Grafana, 1 for Prometheus. This is the Grafana one. If we look down, it's a fairly standard Nginx image that we download. Pretty standard file here. You'll see this exact file in many scenarios. So we'll take it just as it is. Notice that I did link it to the secret, the Grafana TLS secret that we created earlier in the scripts. So that's the one caveat here, is the secret. So let's take a look at the service as well. And notice, in fact, that it's just pointing back to the, it's selecting the Ingress for Prometheus. We do have the ports. So to summarize here, we just have the 3 files we looked at for the Ingress controller. Okay, so let's now run the deploy.sh file. You can see it here in the listing. So it's here. Let's go ahead and do a basic cat on it. You can see the contents. We just reviewed that in detail. Let's just do a bash now and run this thing. It should take a few moments here to fully provision all the components. As you know, there's a number of components here. And so what we want to do here is wait maybe 2-3 minutes and wait for all these different pieces to kind of get produced into the Kubernetes cluster. So here is the final step. You can see that in fact we have created Grafana, Prometheus with Helm, and here at the very end, as we discussed, the various Nginx controllers, which can also be seen in this diagram here. So we have now completed the deployment. There's a few commands we can do to actually validate this deployment. Let's go ahead and clear the screen. We'll do an LT to list a couple of these shell scripts I wrote. They're basically used to kind of look at the provisioned resources, one for Grafana and one for Prometheus. So let's edit them real quickly, and you can see how simple they are. They're just doing a kubectl, get pod services, replication controllers, ingress, secrets for the namespace Grafana and the namespace Prometheus. So just two scripts. They only differ by the namespace. After all, our resources are in separate namespaces. So let's go ahead and now and run the get all. Let's take a look at the Grafana deployment first. We're going to list all the resources. One of the key ones here is that external IP here for the ingress Grafana replication controller. So that load balancer, we need that IP address because we want to go and update my domain registrar for Turkley.com. So we can go to the Kubernetes dashboard. We can see the namespaces. We can see the provision resources. This is a great way to really get a macro view of all your resources. So the core namespaces, as we saw earlier, were the Grafana as well as the Prometheus. So again, we're just kind of jumping around here to show you one way to take a look here. Here are the services. Notice the external endpoint. That's that IP address that we're interested in, because after all, we need to update our DNS registrar so that we can point to Turkley.com appropriately to this cluster. So again, looking at all the different deployments, Prometheus has a number of different components in it. We didn't get into all the details here. The whole point of Helm is that it kind of abstracts it. At any rate, we want to get to this public IP address here, copy that to the clipboard, because we're going to go to GoDaddy here, which is my domain registrar for Turkley.com. And what we want to do here is update the A record. After logging in, of course, we want to update the A record with that IP address. So I'm going to go to my domain, Turkley.com. I'm going to therefore say manage DNS. Go ahead and click manage a couple times here. That was method number one. Go down here and select manage DNS here at the bottom. And at this point, we can go over to the A record and update it. Notice we also have some subdomains, CNAME records, but let's focus now real briefly on the A records. That's the IP address we saw for our external load balancer, the layer 4. Notice also we have Grafana and Prom as CNAMEs here, because that's how we will address our cluster. Now notice NSLOOKUP lets me validate that I've got the most recent address. I don't. It's still pointing to the old address. I'll do it a couple times here to make sure I get the correct address. We're looking for 219, and it looks like we did get it this time, so our DNS domain name server is correct. So at this point, I think we're ready to maybe link up to grafana.turkley.com, as the domain name has been mapped with an IP address correctly, and sure enough, success, we are logged in. Well, we're about to log in here, so once we do that, one of the first things we want to do is connect Grafana to Prometheus to get the performance data of our Kubernetes cluster. So we'll go ahead and give this configuration a name. We'll just call it Kubernetes. For the type, we'll go down to Prometheus. Multiple types supported. Now here is where we connect up Grafana to Prometheus. HTTPS prom.turkley.com. We'll go for a direct access here. And once we do that, we can add and validate here with a save and test that it's working, which it is. Now the next step here is to actually import a dashboard here specific for Kubernetes. And we just saw that one. It's dashboard 3131 by Bart Van Bos. Go ahead and do a load here. And once we do that, we will have a dashboard just pop up here with all the data. Well, we've got success here. All of the steps we wanted to take, we've taken, and we have a functioning Kubernetes Prometheus dashboard, which is fantastic. So at the end of the day, we provisioned all that infrastructure we set out to provision to enable a Prometheus solution on Azure. So this ended up being a fairly ambitious effort. We did have to work with a number of technologies: Prometheus, Grafana, Kubernetes, Helm, Nginx, Ingress, wildcard certs. But that's what makes it all worthwhile, to kind of put all the pieces together. And this is a very valuable capability to really analyze the performance of a Kubernetes cluster. So to wrap up, I'm Bruno Turkley. Thanks for watching and good luck.